Okay, let's begin with the first section. In the first section, we have I2C communication, or you can say inter-IC communication protocol. Inter-IC communication protocol was used by was used, inter-IC protocol was a method that was used to communicate between two ICs. It is similar to serial communication between a computer and a microcontroller, but it is designed to communicate between two microcontrollers, or you can say two ICs. It can communicate between a microcontroller and a different type of IC if it supports I2C protocol. Okay, let's just talk about I2C. I2C has a 4-wire channel, 2 for power and 1 for serial communication, which means for serial data transmission SDA, while another for serial clock, which gives a stable clock time between the two, which makes a stable clock time between the two microcontrollers. This protocol is very important because it can be used to communicate with a multiple number of ICs where one act as a slave, where one act as a master, while there can be a number of slaves between a single channel. And if a microcontroller want to call the number 3 IC or number 3 slave IC in the channel, he can call it by using number 3 and giving the pull-up registers call or a high value. While if you want to call the number 4 IC, he can just give a high value to the pull-up register of serially connected slave number 4. By this method, you can communicate with all the ICs which are required by calling their pull-up registers. They all are connected in the same wire. There are only 2 wires for interfacing, one for SDA, that is meant for serial data transmission, and SCL, that is meant for serial clock. In this 2 wire going out from microcontroller, you can connect a number of communication devices or the slave ICs within it, and each one has a special dedicated number or a pull-up register value for it. For that, whenever the microcontroller requires, he can call any one of the ICs as it is required. Okay, there is a built-in library in Arduino that is called wire or wire.h. You can call the wire.h library and communicate between the Arduino and the other ICs or other Arduino boards. This communication protocol is also similar for Raspberry Pi, but it has its own dedicated library, as well as for other microcontrollers, but they had their own custom-made libraries. Okay, let's just begin with an example. First of all, let's just see its wiring. In this, you can see that there is only 2 wire. One is pin number connected to analog pin number 4, and that is going to slave pin number 4 also. Wire number 5, that is going to slave pin number analog 5, and one is for ground. But here in the setup, you can see that we have 4 wire. One is for power, because I am doing a test, that is if we can possibly control 2 microcontroller with the same power source and have a serial or have a I2C communication channel between them. And let us just begin with writing a code. We have seen the wiring, and there is an example code here. Let's just begin with writing the code. Okay, come here. First, for the I2C communication between two ICs, we have to write 2 different type of codes in both the ICs. First of all, a code that is for master communication, or for the master that is required to call different number of ICs, is called the master code, that will be fed to the Arduino that is connected to the computer, while there will be a second code that is implanted into the slave. The code for the slave is same for as number of Arduino devices that you are connecting, but each have a different, you can say, address for communication. I am showing you the example. Just see the Arduino. First of all, for removing any type of confusion, I am just going to remove all the other wires from the Arduino. Okay, you can see that the Arduino is standalone. There is no wire connected to it. You can see here. Okay, let's just upload the slave code first. Let's just talk about the slave code. Okay, here is the slave code. You can see here, first of all, we are calling the wire library. After calling the wire library, we are calling it wire.begin, same as serial.begin, but in this case we are communicating on wire, and it is giving the number 8, so that if we are calling it on 8, then its physical address is 8. So whenever the master is calling number 8, it will be calling this IC. Okay, second, wire on request, and it is giving a function. Okay, delay in the loop, and let's just go down to the function. It is saying nothing, but it is saying a simple line, that it is saying wire.write hello. You can say it can give 2 lines. Okay, write wire.write wire.write. You can give another line for that. I am, say simply wire.write IC2. It is its position, or you can say slave IC, SLAVE, slave. Okay, it is giving 2 lines for the master to read. Okay, just upload it to the board. We are going to save it as I2C SLAVE, slave. Okay, it's going to save. Just wait for a second. Okay, my mistake, I have not terminated the line. Okay, I have terminated it. Now we are going to save it. Again, what is the problem? Wire.slave expected before token. Okay, let's just upload it. My mistake, there was a curly bracket mistake. Okay, I am going to upload it to the board. Just wait for a second, it's uploading. And you can see that it is compiling and it's uploaded to the board. Now one important thing about Arduino Uno is that we can remove the IC simply by using a simple screwdriver. So I am going to remove this IC and connecting it to another specially designed board for the communication of slave protocol. You can see here it has no FTDIRL IC that is used to communicate between the microcontroller and the computer. In Arduino, you can see here this is a small IC. Here you can see this is a small IC. This IC is used to communicate between the computer and the microcontroller, while here there is no FTDI IC, so you cannot communicate with this board and the computer. But this IC is going to plugging in into this board. Okay, I am going to remove the IC from Arduino. Wait for a second. It's been successfully removed and it is going to plug in into the another microcontroller board without FTDIRL communication. Okay, it is successfully embedded into the another board. Okay, now about Arduino, remove the plug, go there and connect it with another IC. Okay, you can see here there are 2 ICs on 2 different boards. Okay, and this IC here in the Arduino is going to work as the master. Wait for a second, I am just going to connect it to Arduino properly. Okay, the IC is connected successfully in Arduino, and let's just plug it. I have plugged it successfully and the button is lighting. Okay. Okay, now we are going to talk about the master program. Come here, we are going to talk about the master program. See, for I2C protocol, the master is simply, it's saying that wire.h for calling wire library, another word string C. We are giving the variable C a value of string so that it will be reading string. Similar, wire.begin for calling the wire protocol, serial.begin so that we can see the data on the serial monitor. In void loop, it is similar, wire.request from. So it is saying that it is requesting port number 8 and the data will be coming in a 6-byte value. Okay, then next, if wire.available greater than 0, you can see that C will be holding the value that is coming from wire.read string and the value that will be coming from the slave, and then after we will be going to print the C. Okay, let's just upload it to the board. It will take about a few seconds. Say I2C master. It's going to upload it in the board. Just wait for a few seconds. And it's successfully uploaded. You can see here. Okay, now I am going to connect the 2 boards same as the wiring as shown here.